Hey, my name is Priya, and today I'm going to be talking about military technology and its advancements during World War II. Throughout this presentation, we're going to hit four key points: the creation and use of radar, the advancements in electronics, medicine and surgery, and finally, the atomic bomb. Starting off with radar, more specifically, I'm going to be focusing on the Downing system, the cavity magnetron, and meteorology. Radar was discovered by Heinrich Hertz, a German scientist, during the mid-1930s. It was initially used for combat, specifically for communication. This is because radar could travel over long distances. In addition, radar was used for detecting other objects. This is done by sending waves out that bounce back, giving the user an idea of the size, speed, and shape of an object. This is great for spotting enemy airplanes, ships, or submarines. This is also great because people could see 100 miles away, even at night. Later, post-World War II, radar was used for telephones, food prep, weather forecasts, and meteorology. Over here is a picture of Wurzburg in France, which at the time was German occupied. It is an 8-meter wide dish antenna and is part of a system for detecting incoming airplanes. How radar works. Radar is basically a detection system with radio waves, and using it will tell you the range, angle, and velocity of an object. Just to reiterate former points, it was used for detection of aircraft, ships, guided missiles, vehicles, weather formations, terrain, and so on. It is a tube base and has a single band. Radar is operated at one frequency. This is because frequencies can easily be intercepted or jammed. But as technology advanced, obviously radar systems could be operated in multiple frequency. And over here is an example of radar, and you can see the tube base and the single band over here. The Downing system. So this is an example of radar in use during World War II. The Downing system was the first ground-controlled interception network for the Britain's air defense. It controlled the intelligence and communication of orders during enemy raids. And over here is a picture of radar receiving towers and bunkers at WWII Bay. So here are some practical uses for radar. The cavity magnetron, otherwise known as microwaves, was created by Percy Spencer. It changed the way Americans prepared and consumed their food. The microwaves produced shorter and micro wavelengths using the cavity magnetron, improving the pre-war radar technology and also resulting in increased accuracy of radar over greater distances. After the war came to the end, the cavity magnetron found a new home away from warplanes and aircrafts and instead in an American household. Actually, the cavity magnetron came about when Percy took note of a candy bar melting when he was stood in front of an active radar set, and this led to experimentations using different foods and ultimately the commercial microwave production. And advancements in meteorology were also made. The development of radar improved the study of weather post World War II, and there was an overall advancement in knowledge of weather patterns, predictions, tracking, and planning for daily changes in the weather. Now we will look at electronic advancements, specifically at computers, calculators, and code. Here are some key advancements made in World War II. The Colossus, the first electronic computer. It was designed to work in concert with the bomb, which was an electromechanical device used by British to decipher German Enigma machine encrypted messages during World War II. And that brings us to Enigma ciphers, which was used by the Germans to create encrypted secret messages. The Mark I was the first US developed computer by Harvard Mark, and it was an electromechanical computer built by IBM by Howard Inken. The Mark I used electricity to turn wheels on rotos, powered by relays and controlled by switches. The Mark I was replaced by a series of models up to the Mark V. Mark III included more electronic components and tubes, and the Mark V removed all mechanical components, storing memory and a magnetic core. The Wrens was a women's Royal Naval Service, which operated many of Britain's Colossus code-breaking machines, and the Waves was a group of about 600 Navy women, and they used different machines to break German codes. And finally, the first program run on a computer was written by John von Neumann, who was comparing the efficiency of implosion and gun mechanisms to trigger the first atomic bomb. So over here are pictures of the development of computers, showcasing the Colossus, Mark I, III, and V. You can note the dramatic change in size throughout the time as well, comparing the Colossus to Mark V especially. And here's a picture of Turing's bomb, which was used to decipher encrypted messages. Advancements in medicine and surgery, focusing on penicillin. The features of this topic include blood transfusions, where they freeze-dry blood and put it back into another person. This allows another man to get more blood. Skin grafts, where they found skin on one piece of the body or one part of the body, and they moved it to another part to keep a wound unexposed. And finally, trauma and antibacterial treatment, benefiting many of the soldiers on field and post-World War II. So the initial problem was that soldiers were being sent off to war, and they had to fight in the middle of nowhere on a battlefield. So if they get injured, there is going to be a high percent mortality. So by finding these medical advancements, soldiers were able to be patched up on the field, stabilized, and kept alive. Penicillin. Penicillin was discovered by Sir Alexander Fleming by accident on September 28, 1928. It was forced by deep tank fermentation, discovering the process needed for mass manufacture of penicillin. Overall, penicillin is responsible for saving millions of lives and warding off bacterial infections. And here is a picture of Alexander himself. Penicillin, since it's been used, has saved from 80 million and up to 200 million lives. And this number only continues to grow. So this really puts into perspective about how important penicillin really is. And finally, the fourth area of focus is the atomic bomb, focusing on the Manhattan Project and the attacks on Hiroshima and Nagasaki. Now here is a map marking the areas where nuclear weapons were either under development and never finished or fully developed. The US developed the first nuclear weapons during World War II in cooperation with the United Kingdom and Canada as part of the Manhattan Project out of fear that Nazi Germany would develop the atomic bomb first. The United States was actually the only country who launched the atomic bomb on Japan, which will be talked about later. The Manhattan Project was a government project. The goal was to get an atom and split it to create a huge outburst of energy. On December 28, 1942, Franklin D. Roosevelt ordered the formation of the project. And basically, it grouped together a bunch of different scientists and military officials to work on nuclear research. The research occurred in Los Alamos, New Mexico under J. Robert. The Trinity test was the code name for the first nuclear device on July 16, 1945, their testing under the project. And it was mainly known for a huge cloud of smoke it produced, the mushroom cloud as it's called, because it looked like a huge mushroom in the sky. And Hiroshima and Nagasaki. On August 6, 1945, the bombing of Hiroshima and Nagasaki occurred under Harry Truman's presidency. Prior to the bombing, the Potsdam Declaration was released, defining terms for a Japanese surrender, and if they didn't follow those terms, they would face utter destruction. Overall, the dropping served as a notable marker to ending the fighting in the Pacific competition for dominance that propelled the US and Soviet Union to manufacture and holding as many nuclear weapons as possible. There were two bombs the Little Boy and the Fat Man developed, dropped by a B-29 bomber plane called Enola Gay, and the results were pretty tragic. There was about 80,000 deaths instantly and thousands of deaths later on due to radiation exposure. And here is a picture of Hiroshima post bombing, and the circle indicates the target area. Here's a picture of the atomic bomb dropped over Hiroshima called the Little Boy, and it has 15 kilotons of TNT and is the first nuclear weapon deployed in wartime. And finally, here's a picture of the atomic bomb, the Fat Man, in transportation. And it is a plutonium bomb, and it was the second to be dropped by the US in World War II. And here's my works cited. Thank you for listening, and I hope you found this presentation interesting and informative.